In this video, we solve problem 11.5.013 from the Larson and Edwards Calculus Early Transcendental Functions text, 7th edition. We're asked to find a set of parametric equations and a set of symmetric equations of a line that passes through the points, if possible. And for each line, we're asked to write the direction numbers as integers. So first for the parametric equations. The way I like to think about this is I'm starting at some point over here, and this other point is over here. So I'll call this my point A, and I'll call this the point B. So A is at this location and B is at this location. Well, if I want a direction vector for the line, I can just find a vector that goes from A to B. That will definitely give me a direction vector for the line. So we'll just say the vector from A to B is this. You take the coordinates of B, which are negative 2/3, positive 2/3, and 1, and then you subtract the coordinates of A. So that's a 5 and a negative 3 and a negative 2. So we've got negative 2/3 over, or minus negative 15/3, so it's going to be negative 17/3. And then this is 2/3 plus 9/3, which is 11/3, and this is 3. Now, I could just use these as my components, A, B, and C for my direction vector for a line if they didn't give me this instruction. They say for each line, write the direction numbers as integers. Remember, the direction numbers are the components of that vector V. So for V, I could use this, but in order to follow this requirement from WebAssign, I need to get rid of the fractions. And I'd like to make this a positive coefficient as well. So I think what I'll do is I'll take the vector AB and I'll multiply it by negative 3. That will be the direction vector for my line. So when I multiply this by negative 3, I get 17. When I multiply that by negative 3, I get negative 11. And 3 times negative 3 is negative 9. So those are it's my direction vector. Those are the components, A, B, and C. And this here can be my x naught, y naught, z naught. That's any point on the line. So my parametric equations are given by these formulas. X naught plus AT, y naught plus BT, and z naught plus CT. So x naught is 5, y naught is negative 3, and z naught is negative 2. And then we're adding 17 times t for our x value, and we have a negative 11 times t for our y and negative 9 times t. So those are my parametric equations, but the way we enter them in WebAssign is like this. They don't like to write x of t, y of t, z of t. They say enter your answers as a comma separated list. So I'll type equals 5 plus 17t, or x equals that, y equals negative 11 or negative 3 minus 11t, because adding negative 11t is the same as subtracting 11t. And then the last one is z equals negative 2 minus 9t. And so that's my answer for part A. On part B, we're asked to find the symmetric equations. Now remember the form of these, it's this, x minus x naught over A equals y minus y naught over B, and that equals z minus z naught over C, where our A, B, and C are right here, and our x naught, y naught, and z naught are these numbers. So we can just substitute into this formula. Now, if you're wondering where these formulas come from, it just comes from taking these equations and solving each of them for t. If I take this one and solve for t, I get x minus x naught over A is equal to t. If I take this one and solve for for t, I get y minus y naught over b is equal to t. So if we solve all of these for t and then we set them equal to each other, we get this. So that's the form. Our A, B, and C are 17, negative 11, and negative 9. And our x naught, y naught, and z naught are 5 and negative 3. So we're subtracting negative 3. That's the same as adding 3. And then we're subtracting negative 2, which is the same as adding 2. So these are our symmetric equations. And I believe we don't actually have to type these in. We're just choosing the right symmetric equations from a list for this problem in WebAssign.